This is section 1.2, and we are going to be working with your graphing calculator today. And a few things that we're going to do, you're going to be able to find a window on your calculator to show a complete graph. You're going to be able to graph a scatter plot from a set of points using your calculator. You're going to be able to graph from an equation, and you're going to be able to find turning points. So several things that we're going to do on a graphing calculator. They are a necessity, and you're allowed to use the TI 83 or 84 or 84 plus for this class. Graphing an equation. A graph is a complete graph if it shows the basic shape of the graph and important points on the graph and suggests what the unseen portions of the graph will be. Important points on the graph are minimums, maximums, and these are called turning points in the book. So if I had a graph that looked like this would be a local max, because it's not the max because this goes to infinity, but it is a local max, and this would be a local min. So we're going to be able to find those using our graphing calculator. This is just some general graphs and what they look like. So a graph is a complete graph if it shows all the turning points on there. And let's take a look at this first one here. So this first one, you should know, because you graduated from Algebra 2, that this is just a line. And a line could look like this, which would have a positive slope, or it could be this way, which has a negative slope, or it could have no slope, or it could have an undefined slope. So those are all linear graphs. The next kind of graph is an even exponent, and specifically y equals x squared. And this graph has one turning point. You probably know what this looks like already. It's a parabola. And this parabola goes through 0, 0, and it goes through 1, 1. And you should be taking notes to be sure that you get the credit for this. And I'll put 0, 0 on here. And couple things that we want to know about graphs are the number of solutions, real or imaginary, equals the exponent. And another thing that we would know about the graphs, I'm going to just slide this down here so you can see it. Oops, I don't have it on here actually. The number of turns is one fewer than the exponent. I'm going to write that down here. And actually I'm going to type it down here. The number of turns is one fewer than the exponent. Okay, so let's take a look at that on this graph right here. So this has one turning point. If you notice, it goes right here. It was going down and now it's going up. So there's my turning point. So one turn, and it has an exponent of 2. So the turns are one less than the exponent. Take a look at the next graph here. Y equals x cubed. These are parent functions, by the way. 0, 0, 1, 1. That's what they go through again. And this function here goes like this. And this is the exception to the rule that I just typed out for you down there. This has no turning points, which means this is going up. It's just going up at a slower pace, and then it's going up at a faster pace. So there are no turning points on here. This one here had one turning point. So that's the exception. I wanted to make sure we got that out there right away. Okay, let's look at these down here. So I'm going to extend this page out for us. So as you saw, this was an even exponent, 2. Other even exponents would be 4 or 6. This exponent would be there, and I'm going to show you just generally what they look like. So if you had, for instance, y equals x to the 4th, I don't know what the graph would be, but it would kind of look like this. So I'm expecting 3 turning points. Let me show you where they are. Here's one, here's the second one, and here's a third one. So this has 3 turning points. We're just graphing these by hand. If it was to the 6th power, and let's just put that on the same graph here, if it was y equals x to the 6th, it would have 5 turning points. So it could look like this: 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's my 5 turning points because it's to the power of 6. Very similar to the parent function y equals x squared, just a few more turns in it. If it was an odd exponent, more than 3, so it'd be to the 5th power or to the 7th power, any odd. If you had one that looked like this, so this one here has 1, 2 turning points. It'd be y equals, and it could have a number in front of it. That's why it's different than the one above. But there's your cubed, which has 2 turning points on here. Could have y equals x to the 5th power, so that would be 4 turning points. So it'd be 1, 2, 3, 4. So that would look similar to this one. There's 1, 2, 3, 4. So what you're supposed to learn off this messy screen is the number of turning points is 1 less than the exponent. That's the biggest thing you're learning on here. And what an even powered graph looks like, which would be like a parabola, even if it was opening down, it'd still be a parabola. And what an odd exponent looks like. And that's where it's negative infinity and it goes to positive infinity, and there's so many of these little loops in here. Okay, get out your calculator. If you need to pause this for a second, you can do that. We're going to graph these equations and find their turning points with your graphing calculator. So if we take a look at this first one here, we know this is a line, right? So I'm just going to put this on my calculator, and you might want to write some directions down for your calculator so you know how to do them. I'm going to go into the y equals button, which is right here, and I'm going to just clear this out. I'm going to go down and I'm going to clear this out. So if you need to rewind this at all just to see this again, by all means do that. So I'm trying to graph 2x minus 5. So here's my 2. The variable x, or whatever the variable is, it doesn't matter. The variable is going to be right here. You always use this button here for a variable. Minus, make sure you use the minus sign, not the negative sign. So very different. You'll get a syntax error if you do that wrong. Minus 5. And then we're going to just do a zoom 6. And that's just going to give us a 10 by 10 graph. So if you look at here, here's my one screen that I was on. Yours doesn't show this, but mine does. Here's my table, which we're not really using, but it did populate. And then here's my line, and I predicted it was going to be a line based off of the last screen. So I would say on that screen, you're going to graph it. We can graph it by hand even. 1, 2, 3, 4, 5, up 2 over 1. And here's my graph. And I would say no turning points. Looking at the exponent is to the first power, 1 less than that would be 0. Second question here, I know it looks like a parabola of some sorts. I'm expecting 1 turning point on this. So let's take a peek at this one. So I'm going to put this on my graphing calculator also. So I'm going to go to my y equals again. I'm going to clear that first y1 out, and I'm going to put in 1 divided by 2. There's my fraction. And then x squared. And I'm going to still do zoom 6 and see what that one looks like. There we go. And I'm going to go back to my page. So I'm going to actually go ahead and put that one in there. So it's going to look similar to this one right here. And again, I am expecting, which it shows, 1 turning point, which I would expect because of the 2. Okay, let's sketch this graph on our graphing calculator, and then we're going to follow the directions on this one. So if we go to our calculator again, we're going to go to the y equal, we're going to clear that out, and we're going to type this one in, which was x, and then we're going to do the caret key because it's raised to the 3rd power. Some of your calculators, depending on the version, will already be down in the base, but I have to actually do my arrow over one so it drops down so I can put the minus sign, make sure it's the minus sign, 3x squared minus 13. And then the directions said use zoom 6 and look at the graph. So I'm going to do that right now. I'm going to go zoom 6. It just gives you a standard graph. And we're going to take a look at that. And notice, what were we looking for on this one? So I feel like we were looking for a graph that was similar to one like this. Because it's to the 3rd power, so I'm thinking it's going to have 2 turns. It's going to start at negative infinity and go to positive infinity. That's what I was predicting. Another thing that you can look at here is this here is going to be the y-intercept, always, which is 0. If I put in a 0 for x, these two are both going to 0 out, and I'm going to be left with the output, the y, as negative 13. So, as you could see on your graph, you couldn't really see all of it because it comes down and it's probably down here somewhere. So they want us to use the windows. If you look at your notes again, use this here for x. So those are your min and your max for x, and then these are the min and max for y. So we're going to do that and see if we can see it better. So I'm going to go to my window, which is right there, and I'm going to use negative 10, which is already there, 10. I'm going to skip the x scale because I want it to be 1, and then negative 25, and my y max is going to be 10. And now I'm going to regraph it. And now we feel that that is actually a complete graph because it has 1, 2 turns, so it's showing the entire graph. The last one was just showing this part right here. And these, I just want to make a note, these are not interval notations. These are windows. So don't be fooled by that. Okay, so now I'm going to look at what that graph, I'm going to actually draw what was on there actually. So that is my, if you go back to your calculator and actually draw this out. So that's what the graph looks like. And that's a sketch, but we want it to be a little better. It's a sketch and find the turning point. So I want to know what this turning point right here is. That's the local max. In this turning point right here, which is the local min. I want to know what those ordered pairs are. And I'm going to use my calculator to find them. So I'm going to go back. And if I want to find that max, I'm going to calculate. And if you notice, it calculates in blue here. So I'm going to put the blue calculate. And I want to calculate the max. So I'm going to pick number 4. And I'm going to just follow the directions left bound. So I want this little blinky to be to the left of the max. So I'm just going to use my arrows and slide it over so I can see that it's to the left of the left bound. Once it's left bound, I'm going to push enter. I'm going to read the directions again, right bound. So I'm going to move it over on the other side. Make sure you're not past this other one. So it's kind of to the right. So I'm going to push enter. I do not want to guess, so I'm going to push enter again. And I'm going to get a number like this, okay? I want to talk about this number right here, because if you wrote it like this on a quiz or a test, you'd lose a point. So let's take a look at what that means. It's negative 8.206 e to the 7th, if I can remember that. Negative 8.206 e negative 7. That means it's kind of like scientific notation, really. I'm going to move the decimal 7 places, making it small. This is like an exponent. It's like 10 to the negative 7. 7 places that way. So if I do that, I'm going to have negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 8, 2, 0, 6. And we got to round that. And this number with all these zeros is just going to round to 0. So that's just a fancy way of saying 0. 0, negative 13. That is that max there. So I'm going to put that right on here. 0, negative 13. And then I'm going to find the minimum right here. So I'm going to go back to my calculator. I'm going to calculate. So the blue, calculate. The minimum, which is number 3. I'm going to follow the directions, left bound. So I need to be the left of this minimum. So I actually need to go to the right a little bit. So I'm to the left of the minimum. I'm going to push enter. And then it says right bound. So I need to move this to the right of the minimum. Push enter. I do not want to guess, so I'm going to push enter. And this minimum is 2. And again, if you have to round with all those zeros, this is just going to round to 0. So 2, negative 17 is the minimum. 2, negative 17. So there we go with our complete graph with the local max and the local min on there for you. Okay, let's go ahead and try this one. And this one, very similar process. You're going to put this into your Y1. And they want us to use for the window, for the X's, they want us to use that window right there. And then they want us to find the appropriate viewing window for the function. So we have the X one, which would be negative 60, 0, and we need to find the Y. So I'm going to go back to my calculator. I'm going to go to the Y equals. I'm going to clear it out, and I'm going to type in my X squared plus 60x plus 30. And I'm going to go into my window and I'm going to change my first window. It said negative 60 and the max would be 0. And then I'm going to have to find the other window. So I'm just going to leave it as I'll just leave it how it is. I'm going to just graph. So this is the part I'm seeing. Notice how there's the other one right there. So we're expecting it to be a parabola opening up. So it must come down like this and back up like this. So I need to adjust my window. I need to see what's down here. So I need my Y minimum to be much lower. So I'm going to just pick negative 100. And I'm going to graph it. Notice I still can't see it, so I need to get bigger on here because it's still down here. So I'm going to go back to my window and maybe I pick negative 1,000. See what I can see. So I say just go big. If you need to get down further, just go big. I need to see this minimum, and there it is right there. There's my minimum. And it goes back up. And this is going to be from negative 60 all the way to 0 on this. So that's what my graph is going to look like. So I'm going to go ahead and I use for my window for my Y, I use negative 1,000, 0. So that's going to be my Y. Okay, find the coordinates of any turning points is my next thing that I'm asking for. And can't find my recorder for some reason. So find the coordinates of the turning point. So here's my graph. It's going to go from negative 60 to 0. And I'm going to calculate, there's a minimum here, so I'm going to calculate the minimum, which is number 3. And it says left bound, so I need to be to the left of it. Push enter. Right bound, so I'm just following the directions here. I'm going to go to the right of it. Make sure that you're above that, so you're to the right of it. I don't want to guess. And my minimum is negative 30, negative 870. So looks something like this. And this here is going to be negative 30 and negative 870. You could probably write nicer than me on yours. And that's all it's asking me to do. I try to go really slow on these. You can always rewind them and check them yourself. Next is with the table. And okay, so now we're going to take this table and we're going to make a best fit graph out of it. So here's my x's, here's my y's. So I'm going to go to the calculator and I'm going to put this in the table. So I'm going to take the stats that I have, and I'm going to enter them. So stat, enter. You might want to write some of these directions down because you're going to need them for your homework, so you know how to get there. First thing I want to do is clear this list out and make sure it's 1, 2, 3, 4, 5. For surely 1 and 2. So I'm going to just go up with the arrow. I'm going to clear it. I'm going to go back down. So I'm going to put those X's in that you saw, which was a 1, enter, 3, enter, 6, 8, and 10. And after the last one, it's not entered in until you push enter. And then I'm going to slide over. I'm going to do the Y's. So make sure you do a negative, not a minus. So negative 10. Otherwise, it'll error out on you. 0, 15, 25, 35. Okay, now that we have our points in here, we want to create a line, and how we do that is we're going to do stat, and then we're going to calculate. Actually, we're not going to do that, so I'm going to have you quit. So you see the blue quit here? Just do the blue button and then quit. So those points are in the table. They're right here, actually. And I want them to populate on my graph. So I need to go into the stat plot. So it's going to be the blue stat plot. And I want to turn my plot on. So I'm going to push enter. And I'm going to turn my plot on. So I'm just going to push enter one more time. And then you can get off of it. And you see how it's on. And it's going to graph a scatter plot. And it's going to take it from my L1 and L2 list where we just put our X and Y's. And now I want it to graph. So before I graph this though, I want to go into my window, because if I go back to my sheet here, I already know my window, which is really easy when you have the raw original data. My X is going to go between 1 and 10, and my Y is going to go between negative 20, negative 10 and 35. So I'm going to go just a little bigger and smaller so I can see that a little better. So my window, I'm going to make from 0 as the minimum, and then it went to 10. So I could put 10, but I'm going to go maybe 12 just so I can see that dot so it's not on the edge of the screen. And then my Y's went from negative 10, so maybe I go from negative 12, go a little bit bigger, window to 35, so maybe I go to 38. You could pick 40 if you wanted to. And now I'm going to graph. And as you can see, I've got 1, 2, 3, 4, 5. These are my points that, not right here, but those are the points that I put into the stat enter. Notice that this other graph is still showing here, this line here. So how do I get rid of that? I go into my y equal. I notice that my plot is on because I put it on, so it plotted the points, but I don't want this graph to be on there. So I'm going to just clear that out, and then I'm going to regraph it. And when I regraph that, that's gone now. So the next thing that it asked me to do is B, use the graphing utility to graph the equation. So now I want to graph this equation on the same set of axes from the A. So if I go back here and I'm going to go into my y equal, now I want to graph this. It was 5x minus 15. And I'm going to graph it on the same graph. And notice it goes through every single one of those. So I'm going to go back to here, and it says using that. So I did that. I graphed it. So the first one looked like this. 3, 0, 6, 15, 35, 10. Looked like that. And then the second graph kind of went right like that. C says, do the points fit on the graph of the equation? I would say yes. Do the respective values of x and y in the table satisfy the equation in part B? And I would say yes for both of those. Okay, last problem. Suppose that the cost C of removing P% of the pollution from drinking water is given by the model. So it says use the restriction of P to determine the limitations on the horizontal axis, which is the x-axis values. So if I look at the P here, first of all, we know that P cannot equal 100. And why do we know that? Because we learned this in the toolbox that a denominator cannot equal 0. So it says use the restriction of P to determine the limitation. What does P represent? P represents percent. So the limitations or the limits on here, the P would go between 0, because you can have a 0%, so I'm going to do greater than or equal to. But it has to be less than 100. It can't be equal to 100. So that is the answer for A. Let's go to B. Graph the function on the viewing window. So they want this to be the x limits, the min and maxes, and this to be the y's. And I'm going to graph this. So let's go ahead on our graphing calculator. I'm going to go into the y equal. I'm going to go up and turn my plot off. So I'm going to push enter. Oops. Up, enter, off. And when you go up, push enter, you notice it's not darkened anymore. And then I'm going to clear this. And then one thing I want to talk about on this, in our calculator, we got to make sure that we put a parenthesis around this bottom one because it's the top divided by the bottom. So we want to make sure that this is 1 unit here in order for this to work. So when I put that in, I'm going to put in 5350, and they don't have any p's, they just have the plain x divided by parenthesis 100 minus p, and again we're going to just use x parenthesis. And they wanted us to use the window, so I'm going to go back to the window. And they wanted us to use 0 to 100. And then the x or the y window, they wanted us to use 0 to 50,000. And now I'm going to graph it with that window. And I'm going to get that right here. So that's going to go from 0 to 100. Okay. Let's go back to our question. That's my graph, so you're going to actually portray that here, right? So you're going to go from 0 to 100, and it's going to go like this. And this is 0 to 50,000 is where we went to on there. So that's the windows. Notice how they're on here. So it says why is it reasonable to graph this model on a viewing window with a limitation of the cost being greater than or equal to 0? And the answer to that is cost for something cannot be negative. Okay. C, find the point on the graph that corresponds to P equals 90. So this is something new on our graphing calculator. I hope you're taking good notes. Maybe you have a graphing calculator page just to help you with the sequences on there. So they want to know if P is 90, find the point on the graph that corresponds to P is 90. So what you can do then is you're going to go to your calculator, and I'm going to do the blue calculate a value when X is 90. And then if you push enter, when X is 90, it kicks out to you 48,150. So it does all that for you. I expect you to do all of that on your calculator. And if you do that, that was going to be calc value of 90 and push enter. So you're going to get 90, 48,150. Interpret the coordinates of this point. Anytime you're interpreting, you're making a sentence out of it. So if I was going to interpret that, I would say the cost of removing 90% of the pollution from drinking water is, remember C was cost, this was P, this was C. So this would be money, $48,150. Notice in my sentence, I define the 90, what it meant, and I defined the 48,150, what it meant. So just one sentence answers C. Okay, so this is your homework. I have some hints on you for number 1 and number 17, and then 19 through 24. So you're going to follow all the directions, but 19 through 24, I want you to graph, list the windows that you use, and list the turning points, whatever those are.